myself quickly. Okay, so what we are looking at is I give you the purple line. The purple line is the resultant. Okay, be careful. This it depends on the question. The purple line like this might not be the resultant. Okay, but you've just got to read the question carefully. In this case, it is. Okay, so I give you the resultant, and it's a purple line. If you are drawing a line that is not on a Cartesian plane, you draw it as purple. Okay, because it means that it will have a blue part and a red part that will be on the Cartesian plane. Okay, doesn't matter which one you draw as red or which one you draw as purple, as long as your verticals are the same color and your horizontals are the same color. Okay, so your blue over here would then be called the y component or the vertical component. Okay, so if you think about it, we are actually replacing the purple line with a blue and red one that will do the same job as the purple. Okay, because remember the purple line is the resultant, and the resultant is the single vector that will do the same as the other two combined. So now we are looking at those other two instead of just the resultant. Any questions here? Am I confusing anybody here now? Speak now.
No, ma'am.
You're all okay?
Ma'am?
Yes?
Ma'am, what do you mean by the purple line might not be the resultant?
Okay, so let's consider if this was not force, for example. If we consider a displacement, okay? And let's say I walked in that direction and then I walked down and I stopped. What is the resultant? So now this y value here is actually the resultant. Okay, because I walked up there and I walked down there and then I stopped. So what would be the single vector that replaces the walk up there and the walk down there is that walk over there. Okay, so it does depend on the question. And very often it is a displacement one. Okay, like I said to you, the displacement one often uses head to tail method, whereas forces and velocities use the tail to tail method, which is this. Okay, so it just depends on the question. All right, you'll see a question and the arrows, actually, the direction of the arrows. Okay, so how are we going to do this? Now, what you would normally do is you would do trigonometry. Okay, now you obviously don't see an angle here. I haven't given you an angle, but because it's on a Cartesian plane, you can see that this y component is going to be 5, and let's consider it as a force, so 5 newtons. Okay, if we look at the x, we can see that it goes to 6, so it will be considered as 6 newtons, and it's going to be to the left. Oops, sorry. And then remember, this one also needs a direction because it is also a vector, so up. Okay, 6 newtons left, 5 newtons up. Okay, so that's broken that one down. Now I'm going to show you something else. Now, have a look at this. This is a man who's pulling a box, and he's got a rope over there. Okay, and that's tension. He's got tension force over here. Oh, I think something happened to my, let me just check my page on my computer, because I used to have a value there as R. Might have just slipped away because it was a text box. So I'm just going to check if it is still there and what it was. I think it was 5. I think. No, I'm not sure. Let me just have a look. Mechanics 2020. Okay, I'm on there. I'm just taking a look. Oh, yeah, the text box moved a little bit, so it covered it. Let me just see what it was. 4. Okay, this is 4 newtons. Yeah, sorry about that. It was on there, but Okay, so we have that resultant. Okay. Now we have an angle. The angle here is 38. So if we had to consider this on a Cartesian plane, okay, remember this is because this is your let me just get my pencil. Because this is your object, remember you can make it your origin of your Cartesian plane. So there you can see you have been given a purple line because it's not on a Cartesian plane, so it is like a resultant. Okay, and now you're going to need this next year more than you needed this year. Okay, because next year we start working things out with the motion and we start working out friction and things like that. And remember, this box is going to move in the horizontal direction. So the only force affecting it in the horizontal is going to be the x or horizontal component of that force. Okay, I don't need you to understand that now. All I want you to do is be able to work out a resultant into its two components. Okay, that's all. So if you're feeling a little overwhelmed, all I want you to do is be able to go from the purple to the red and the blue. Okay, or from the resultant to the x and y components. Okay, so let's go with the same colors as what we used here. So if I was to do that, you can see I've just drawn that over there. It really doesn't matter how long you draw that arrow. Okay, because we've got the value on it. So there is my red component, my x component. Okay, and then if I was to do that, I can pull that back. Oops, put down there. And there is the blue. So we are breaking the purple up into the red and the blue because the red and the blue make the purple. So basically I'm saying I'm replacing that purple one with a red and a blue. Okay, because next year you are going to need them. So let's take this triangle out so that you can see exactly what we're doing. Okay, so here is my triangle. Okay, 90 degrees is over there. It has to be 90 degrees. This is 4 newtons, and we have a 38. It is a 38. A 38 angle, and this is the angle that they've given us. Now, if you remember your rectangle, remember when we do this, we make a rectangle. That means that that side is going to be our y component. It's going to be equal in magnitude. And this is going to be our x component. Okay, now you'll see at the top here I've said Rx and Ry. We can represent them as, yes, our R was 4, but if I break it up into the R's Y component and R's X component, okay, we can refer to it like that, but you really don't have to. In fact, I'm not going to. I'm just going to talk about an X component and a Y component. Okay, so let's do some colors so that we can see what's going on. Now I've got my purple line over here, and we keep them in the same order, the same direction. We've got our red one over here. So all I've done is I've redrawn this over here. Okay, I've redrawn it over there. So now we can look at our trigonometry. I need that one, and I need this one. So what's the one we have? Remember, we've got Pythagoras. We've got hypotenuse. Okay, we've got hypotenuse, opposite, and adjacent. So we know that our hypotenuse is 4 newtons. Okay, would you agree that the y component is our opposite in this case? Okay, because it is opposite to the angle that we've been given. and we are touching and right next to the x component, which means that one is our adjacent. So this is our x component. Okay, so I want to now work out the y component. So that would be opposite over hypotenuse. So you need to have hypotenuse because it's the only one we have. And we know that if you have a look at the previous ones that we did with our ratios, that is sine. The ratio opposite over hypotenuse is sine theta. Okay, so opposite is the y component. Hypotenuse is 4. We have sine, and the angle is 38. Please remember, we don't do shift here. The only time we shift is when we are trying to find the angle, but we've been given the angle. So this is really just maths now. So this works out to be 4, because if we take that up there, 4 sine 38. Okay, so you can put it in exactly like that. I need to take this off now so I can see you guys again. Okay, so if you can see here, I can then go 4 sine 38. Okay, and my y is equal to 2,46. And it's newtons, so you check your units. That's actually what a lot of you did in your previous question, the task. A lot of you lost a mark in your last answer because you gave it to me in newtons, but it was actually velocity that you had to work out. So just check that. Okay, so let's just double check. Does it make sense? Is it smaller than the hypotenuse? Yes. Okay, so I'm happy. It makes sense. All right. Now let's do, so this is the y component. Let's do the x component. So the x component, if we have a look, remember, it is the adjacent. So it's the adjacent over hypotenuse. And that is equal to cos theta. Okay, you'll learn the ratios on your own eventually. It will just come as second nature to you. Okay, so right now at the moment you can look them up. Okay, so just keep them ready with you when we do this and when I give you a task so that your ratios are there ready for you. Okay, so adjacent over hypotenuse. So our adjacent is our x component. Our hypotenuse is 4. We know it's going to be cos 38. It's the exact same angle. And again, I can take the 4 up there, which then actually multiplies with the cos. But remember, you don't have to show it. So we land up with 4 cos 38. And I get x is equal to 3,15 newtons. Okay, and there we go. So now I can use them separately as a blue and a red, or I can use it as a purple, depending on the question. All I want you to be able to do is to break it up from that purple line into the red and the blue. That's all I want you to do this year. Okay, so I'm going to give you an example now quickly, and I want you to try. So I'm going to give it to you on a Cartesian plane. Okay, so example. And I'll go through this with you when you're done. Sorry, this is very skew, I see here. Okay, and I'm gonna shake this up a little bit. I'm actually gonna give you two to do. I want you to try one over here. Okay, follow the steps. I'm going to give you an angle between there and there of 40. Okay, and the R is going to equal 7 newtons. So this is number 1. And then number 2, I'm going to, actually, let's do number 2 and this one number 1. So do a normal one like I just did first, and then let's see. So I'm going to give you that. Okay. But this time I'm going to give you this angle. So that angle is going to be 60. And your R is going to be, let's just make it 5. Okay, so I'm going to give you a few minutes. I'm going to give you 10 minutes, 15 minutes to do number 1 and number 2. You can copy them down. I'll make them a bit bigger so you can see. Is everything clear there? Can you see everything? So this was 60. And that's that angle. That's 40. Okay, so I'm going to give you 15 minutes. I don't even know if it's going to take you that long. 10 minutes, and then I'm going to go through it with you. Any questions? Does it make sense? Should I put do you want to see the ratios? The ratios are opposite over hypotenuse is equal to sine theta. And then we've got adjacent over hypotenuse is equal to cos theta. You only need those two. You don't need tan. I told you the tan is only really for to find the angle. But it's not exclusively only to find the angle. Okay, you guys okay? Awami, are you okay? You're my speaker. Awami, are you still there? Awami's not there. Raquel, are you okay? you've got 5 more minutes. All okay? Aren't you girls supposed to all show me your faces? Okay, girls, I'm going to stop you there, and then I'm going to do number 1 and number 2 with you. So what I've done is I've drawn it again over here so that I can have more space. And you can see exactly now how to start this. So the first thing is you're going to extrapolate, I don't know if that's the right word I'm using, but I keep picking up the whole thing. Okay, we are going to go back like that, like we did on the Cartesian plane. And we're going to then have a look at our horizontal component. So we're just going to look at it so that we can now make our triangle. Okay, so there is our red, and here is our blue. So you first start by actually drawing your Cartesian plane, and then going from the point of your purple one down to the x-axis to get your x component and across to your y-axis to get your y component. Okay, so we're going to call this one x and we're going to call this one y. Okay, now if we have a look, we know that we have now got that angle. Now, if you dead set on using this triangle over here, remember you can say 90 degrees because it is 90 from the red to the blue minus the 60, and then you can get that angle if you really want to. It's really no big deal. But I'm going to keep it at this angle, and I can then see I'm going to use this triangle. Okay, that length of the red is the same as that one. So here is my 90 degrees, and now I can determine my opposite and my adjacent. Okay, I'm just going to let these dogs out quickly, sorry. Okay, my babysitting duties are finished now. All right, so when we take a look here, this is my 5 Newton, my purple. But my opposite is now my red one, okay, because it is opposite that angle, and the adjacent is my x. So this is
Matt,
my
sorry but did you confuse the x and y? Because I thought
you're 100%. I did. When you said it, I went, well, that was stupid. Why did I do that? Sorry, that is why. And I keep saying it. Oh, I'm an idiot. Okay, sorry, my bad. Okay, so this is your x component and this is your y component. Just keep going back to your, I think I was distracted with this damn dog there, with the Cartesian plane. Okay, just keep thinking your y and your x, and yeah, you'll be fine. Okay, so this is my x component here, and it's also my opposite. Okay, so I want to work out the red component, and so that is my x component, and you can even tell me which one you're working out. The more you give me in an exam or a test, the better it is for you. So I'm going to work out the x component. Okay, it is opposite over hypotenuse, which is sine theta. My opposite is the x. Okay, and my hypotenuse is 5 because it was a 5 length, and then my sine is 60. Okay, so this lands up being 5 sine 60. Now, girls, you don't have to show me all these steps. If you just show me the formula, the substitution, and the answer, it's really fine. But I'm just showing you all the steps so that you're aware of what I'm doing. Okay, so 5 sine 60. Okay, and I get an x value of 4,33. And let's just check. I said newtons, so it's newtons, and it's going to the right. Okay, the y component now. Sorry. The y component is adjacent over hypotenuse, which is cos theta, because it's this one, it's the adjacent, and I have the hypotenuse, so it's going to be y over 5 cos 60. Okay, and then the y would then be 5 cos 60. Now it can be quite easy to confuse, like as you saw, it's very easy to confuse the two. And you've got to be aware of it all the time, especially in a test, because your y and your x components, we work with them in another way as well. So for now, I'm trying to let you just work out the correct components, okay? So I'm not trying to confuse you with what these forces are and what they mean and whatever. Okay. You happy with that? Okay, did you all get that? I hope so. Let's take a look at number 2. Okay, so again, where do I start? This is terrible. I'm going to start with my x-axis. So I draw from the point to here, and I'm going to then show an x-axis. Okay, I'm then going to take it to the y-axis. Okay, and that is my y component. Right? Now we know that I've been given that angle, so it's just easier to just work with that triangle. So if I do that, I know that that length and magnitude is the same as that one, so they're both red. So I can use this triangle, and here is my 90 degrees. Okay, so again, my x component is the opposite, and my y component is the adjacent. Okay, it's not always the case, so just be careful of when you're doing this. Okay, so let's do x component again. All right, so I have opposite over hypotenuse, because the hypotenuse is the one you've been given. So you must do one with one you've been given. That is equal to sine theta. Okay, opposite is, my x over 7, and that is sine of 40. Okay, so if you do that, it will be 7 sine 40. And I get 4,449. So let's change it to 50. Okay, because it's a 499. So it was a 4,99. Oh, sorry. It was a 4,4995. So if we look at that 9, it changes that up to a 10, which means that that becomes a 50. Okay, so just be careful of your rounding. So that becomes 4,50 newtons, and it's left. Okay, it is a vector quantity, so you need a direction. All right, then let's take a look at the y component. Okay, it is adjacent, because that one is the adjacent, over the hypotenuse, which is the 7, is equal to cos theta. And so we know that it is y over 7 cos 40. And we get y is equal to 7 cos 40. And we get 5,36 newtons down. Okay, you guys all right with that? Did you get it? Is it making a bit more sense now when I did it on my own, or when I did it with you? Please talk to me, girls. I need your input. If you're really not lacquer with this, I really need to know. Should I put a questionnaire on for you guys to answer? I think so, because the rest of you are very, very quiet. So what I'll do is I'll put a questionnaire on that you can answer, just to say how you're feeling about these and what would you like to ask me, okay, so that you don't have to do it in front of anybody, and I can then address it in the next lesson, but I won't obviously talk to you directly. It will be part of my lesson. Okay, so I'll do that for you today. I'll let you know when I'll put it on. It will obviously only be later. I have extra lessons later this afternoon as well, so remember that. So what I want you to do now is I want you to consider page 4. Okay, oh, the first word there is consider. So there are 3 multiple choice questions here. So I'm going to end off the lesson now by you doing these 3 multiple choice questions, and we'll mark them tomorrow. Okay, so I want you to think carefully, especially 1.2. It's quite tricky. Okay, what I am going to say to you is that I want you to consider for 1.2, I want you to consider how do we get the minimum resultant, and how would you get the maximum resultant when you have 2 forces. So I want you to think about that. Okay, and then that would help you with your answer with 1.2. So I really want you to think about it. You've got about 10 minutes left. So you can leave if you need to leave, but I need you to think about these 3 questions and answer them. Okay, don't just randomly pick a value now and you're done. I really need you to think about it. That is what science is about. Okay. Okay, girls. So if you want to go, you can go. But I want these answered by tomorrow, please. Well done.